Hello, my name is Stacy Gua, and today I will be talking about the formation of acid halides, anhydrides, esters, and amides. Depending on the pKa of the conjugate acid of each leaving group, the acid derivative will form. The lower the pKa of the conjugate acid, the more reactive. The higher the pKa, the less reactive. The conjugate acid of Br and Cl had the lowest pKa at -9 and -7. Since they have the lowest pKa, they will leave the fastest. The conjugate acid of NH2 has the highest pKa, so it will be the hardest to take off. Now I'm going to show you how to turn a carboxylic acid into an acid halide. In this equation, SoCl2 is going to be used. The sulfur has a partial positive charge, so this means that the electrons on the oxygen are going to come to the sulfur and the double bond to the oxygen will break. So as you can see here, oxygen has electrons and it's going to the chlorine, and then the double bond is broken. Now as you can see, in step 1, the electrons on the oxygen come back and the double bond is formed, and then it's pushed off the chlorine, and then chlorine leaves. Now chlorine deprotonates hydrogen and the oxygen gets charged. Deprotonate and then charging occurs. The chlorine comes and pushes electrons to the oxygen. The negative charge on oxygen forms the double bond and chlorine leaves, and now you have your acid halide. So just to repeat what occurred, you have chlorine coming and it's now pushing the electrons to oxygen, and then the negative charge on oxygen comes forming the double bond, and then chlorine leaves. And after that you have your product, your acid halide. The next thing on the list is to form an anhydride. This occurs from two carboxylic acids along with heat. That's what this triangle stands for, heat. And then you get an anhydride and you get water, which is leaving. So now I'm going to tell you guys what happens when an anhydride is formed. So to start off, the electrons on the oxygen come out and break the double bond. So the electrons right here on the oxygen come out, breaking this double bond. And then the electrons on the oxygen come out to the hydrogen, and the oxygen gets charged. So here's the oxygen now being charged. And then the oxygen forms a double bond and water is formed. So here a double bond is being formed, and as you can see, water is also present. And from this you get an anhydride along with water. The last thing I'm going to show you guys is how to make an ester. So the first step is that the electrons on oxygen come to the H+, which ends up forming an OH, having a positive charge on it. So the electrons are here, come out to the H+, and also this alcohol, the electrons are here, come and attack this area right here. So now the next step that ends up occurring is deprotonation. So now you have oxygen the electrons on oxygen here, coming out and ending up deprotonating this oxygen right here. So from that, water ends up forming. And water is meant to be a leaving group. So water ends up leaving a positive charge on the carbon right here. And then we have this water right here ending up deprotonating oxygen, forcing a double bond to occur right here. And this is how we get your ester, along with water and H+.